This is a special relativity. What the argument really is we assume the principle of relativity. And we want to show that this implies that no length contraction occurs perpendicular to motion. We're gonna sort of take an argument by contradiction, or maybe contrapositive, which one you're more familiar with. But essentially, we're assuming that there is going to be some length contraction, and then we'll show that this violates the principle of relativity. So when you have let's set up our situation. So let's suppose we have an object or a spaceship, and it's cylindrical. Okay. Yeah. So notice how there's actually lots of directions perpendicular to the direction of the motion, because it's three-dimensional. And then let's assume, and it's going this way, there is some direction perpendicular to the motion which experiences length contraction. For the sake of this diagram, let's say it occurs in this direction. And nice. So let's say there's a tunnel. In path of, and this tunnel is just wide enough, or just big enough, to fit contracted spaceship. So it's not big enough to fit it the normal length. From the point of view of the spaceship, it's going to think the tunnel's moving, and if at all, it's going to think the length in that direction is contracted. Okay, so from the point of view of the spaceship, it's going to collide into the tunnel and not pass through. But from the point of view of the tunnel, the spaceship, so the point of view of the tunnel is pretty much the same as the point of view of us, where we've made all these, direction of motion and assumptions and stuff. So it's actually thinking thinking our assumption is true, whether this contracts. So from the point of view of us in the tunnel, the spaceship should pass through normally. And so now we're in a position to violate the principle of relativity, because, well, the point of view should agree on the essential physics of the situation, because we're both in inertial frames of reference. But the essential physics of the situation should not predict, in one case, a disastrous collision, and in the other, just like a harmless non-event, basically. And if you're convinced that is a violation of the principle of relativity, then we've essentially shown the statement in the contrapositive, or by contradiction.